So in this section, we're going to use a lot of the stuff that we've already talked about, but again, this is what trig is all about, really driving home all these little tricks and equalities and things like that so that it helps you manipulate through some problems later on. So most of these, I think we've talked about all of them. Maybe we didn't really spend a whole bunch of time on these co-function identities. I know we talked about them briefly, but this chart is just in the book, and this one I did not square that one, but that is kind of a big one for the Pythagorean identities. That's the one that usually you see, but all of these would be in game two. The hierarchy of knowing these are, clearly these are the important ones that you really need to know. But I would really know these Pythagorean identities also. The even and odds, you can figure those out as, depending on the problem, and the co-function identities. Those are ones, like I said before, like you'll get a problem, you'll be like, how in the world did they get to there? Well, it's because they knew this one, okay? But you really need to know these all three Pythagorean identities, and obviously these up here also. Keep in mind that on the Pythagorean identities, you can manipulate them around. And so you do want to be able to do that. For instance, sine squared of u plus cosine squared of u minus 1, right? I mean, that could be also something like this. I'm going to run a room. Right, I mean, you need to know those, any variation of those, So I'm not going to do a whole bunch on this first video. We're going to break this section down just like we've been doing. So I really want you to make sure you're trying all of these and really thinking through them. I'm going to have two slides on this first one because there's two pictures here, or there's two parts to number 16. And they talk about, they give you a definition there in the directions. And basically, what this is saying is, this is like an introduction to limit kind of idea. So as x approaches 0, and then they got this little plus sign at the top. So what this is saying is as x approaches 0 from the positive direction. So, we're coming towards 0 this way, okay? And that's what this notation means. If instead they said, x, like that, x approaches 0 with a little negative sign, they mean coming from this direction. Okay, and so depending on the function that you're talking about, that may actually have an effect. On this one, it doesn't make any difference, but that is what the notation is. Wait a minute. Let's do this. Okay, so again, what we're doing here is figuring out what cosine of x approaches. That's what this little arrow means. What does cosine of x approach as x gets closer and closer to 0 from the positive direction? So, they didn't give you a graph, but I think, it definitely makes sense to take a look at these this way. So, we're coming down the x-axis and we're following along cosine, and then all of a sudden we start getting closer and closer and closer to 0, x equals 0. And so then that means cosine is getting closer and closer, or a better way to say it is approaching 1. So this is the second part of number 16. And, again, it's the beginning part is still the same as x approaches 0 from the positive direction. So we're moving in this direction. What does secant of x approach? And again, I suggest that you guys graph these and look at them while you're still, learning them. So really, as x comes down from the positive direction, it's kind of hopping back and forth to all these. But what we're really concerned about when we talk about this kind of notation is x values that are super, super, super close to 0. And so, but still coming from the positive side. So we're over here. And as we get closer and closer to x equals 0 there, you can see that secant of x approaches 1. Okay, so this next This next group of problems, this is going to be the last group. I'm going to do just 20, 22, 24 for you, just so you can get used to it. And I'm going to talk about a couple things about it. And, just as a copyright type thing, this is out of your book, the Pre-Calculus book written by Larson and Hostetler. And I don't think anyone's going to worry about it during this time, but just in case. So that's where I've been pulling all these from. Anyway, it says match the trigonometric expressions with one of the following, and they give us these options A to F. And so, this, a lot of people feel like this is very obnoxious because, this is really a trial and error thing, and you can only apply ideas, okay? And sometimes your ideas are going to work and it's going to be great, and then other times they're not, and then you got to erase it and restart. But that's just part of it, and that's how you learn these things. So, don't get frustrated. Keep trying everything that you can think of. So we're going to look at number 20 first. And again, this is all these identities that I showed you in the first slide there. That's what we're going to use. And, you just got to come up with them and try them out and see what happens. So, we have this cotangent of x, sine of x. Really, the only thing that makes sense to really try would be to say, well, I know that cotangent is, I guess you could go through it. But I'm going to use the quotient identity of cotangent and say, well, this is the same as, this is the same. Cotangent is really just cosine of x over sine of x. And we're still multiplying that by sine of x, and which is always over 1. You multiply these together, and then these would end up canceling. And so then cotangent of x times sine of x, it would be the same as cosine of x. Okay, and that's probably one of them. That's part B, number B there. Okay. So again, you got to just try things out, and maybe they work, maybe they don't. But that's going to be part of all this kind of stuff. So let's look at 22 here. Okay, so we got another product. Anytime you see a square, you should be thinking of those Pythagorean identities. And, the very first one is sine squared of u plus cosine squared of u equals 1. And I think I actually showed you that you can manipulate these Pythagorean identities around. And this one is basically exactly what I showed you then. So we're going to start with that, and that means that 1 minus cosine squared of x is the same as sine squared of x, and we're still multiplying it by cosecant of x right now. Okay, and then cosecant is 1 over sine, so let me move down here a little bit. So then really what we have here is sine squared of x times 1 over sine of x. Okay, and if you need to see it written out, sine squared is really this. Times 1 over sine of x. Either way, you can cancel one of these sines of x, and that means this whole expression can be simplified into just sine of x. So that is f. All right, so now we're going to do 24 here. If I can move it, come on. And so, right away, seeing this, and going off of that first slide where they gave us, where I showed you all the things in the book, all the identities that we're using in this section. I mean, these match up to those co-function ones. So, again, I don't expect you to have all this stuff memorized, but hopefully you do, not all this stuff memorized right now, but hopefully you do in the long run. And so then sine of pi over 2 minus x would be the same as cosine of x. And then cosine of pi over 2 minus x would be the same as sine of x. And that is one of our quotient identities, so that would be cotangent of x. And that would be C. So give these a shot, and please ask some questions.